Hey Bunny, why are you looking so confused?
Well, I was studying some chemistry, but there's something that I just don't get.
What is it?
Have you ever heard of atomic structure? Apparently, it changed over time due to the new findings of scientists.
I don't think so, but I'm sure we can find some people who understand to explain it to us. Let me call Professor Blank. Hello, Professor Blank. My friend, Bunny, and I have some questions relating to atomic structures. Do you mind giving us a quick lesson on that?
Sure thing. Come on over. Welcome, my friends.
Thank you very much, Professor, for giving us a lesson.
This is going to be an interesting lesson. I have just finished the time machine and the real scientists will do the talking. Let's go. Here we are. Our first stop will be in Greece, and we will meet a Greek philosopher, Democritus, from over 3,000 years ago.
Democritus is a Greek philosopher from the 1000 BC.
Could you tell us about your thoughts?
I wondered if matter can be divided into smaller pieces forever, or there is a limit to the number of times that it can be divided. Later, I came to the conclusion that there is a limit to the smallest size and number of cuts. I named the smallest unit atomos, meaning unable to be cut. I thought they were hard particles, made of the same material, but different shapes. Thanks.
Sorry, I don't know your name. Would you mind telling us who you are and your accomplishment in chemistry?
I am John Dalton, an English chemist, and this was the atomic model that I came up with. The solid sphere model. I had 4 theories. First, all matters are made up of indestructible atoms. Second, all atoms that made up of the same element have identical properties and masses. Third, compounds are formed by 2 or more different types of atoms. Fourth, a chemical reaction is caused by the rearrangement of atoms.
Hello, how may I help you?
Tell us about your discovery on atomic structures, please, Mr. Teacher Thompson.
I zapped the atoms with electricity. I realized that some negatively charged atoms had been removed. I named them electrons. I think they float around in positively charged fluids since the positively charged ones are not affected by the electricity. Thanks, Mr. Thompson.
Hello, Mr. Rutherford. Could you tell us about your contribution to atomic models?
This is my model. Basically, it suggests that the majority of the mass of the atom was found in the small nucleus, and that the rest of the atom was mostly empty space. I found out about this by shooting
alpha particles and beta particles. Most of them pass through the particle undeflected. That proves the empty space. However, there is something solid but very massive in the deflected, so I proposed that there was a nucleus in the mostly empty space atom.
Hello, I'm How can I help you?
Hi, Mr. Mokeur. Could you please tell us about your contribution to atomic structures?
I came up with this strategy. I was told that the atoms are the massive, positively charged sphere encircled by negatively charged electrons, and they stay in orbit because positive and negative attract each other. It works in similar way as Saturn and its rings because the rings are attracted to the heavy planet by gravitational forces. Here is a picture of the model.
Well, so you are Millikan. I heard that you have found the charge of a single electron. Is that the apparatus you used?
Yes, that's the apparatus I used.
That looks really cool. How does it work?
The oil drops come from the atomizer. There are 2 layers in this tank. The top layer has a hole where a single oil drop can fall through.
What are those 2 plates?
Hold on. I I'm getting there. Those two plates are charged, so there is an electric field going on. As the oil drop falls down through the second layer, two forces are acting on it. They are electric field, which is pushing the oil drop up, and then there is gravity pushing it down. I changed the magnitude of the electric field until the oil drop stopped moving.
I think I get it. That means the electrical field and gravity forces are balanced, right? But how does that help you figure out the charge of an electron?
Right. I repeated the same steps with several oil drops and performed some math. I found out that the charges were all different, but they were all multiples of 1.6 x 10 carat 19 coulomb.
So that's
Mr. Chadwick, can you tell us how you discovered the neutron? Sure. During this time, scientists were confused because the mass of protons and electrons combined do not quite equal the mass of an atom, so there must be something else in it. They set up experiments where streams of alpha particles hit beryllium and said that gamma rays came out as a result. When these
But wait, gamma radiations are just massless photons, and protons have really high mass, so how are they strong enough to knock out protons?
Exactly. I repeated the same experiment with different materials besides paraffin, and I found out that gamma radiations were too weak to knock out protons. So I proposed the existence of much massive particles, neutrons.
Well, that was amazing. We learned a lot.
I still have another question. Now that we have seen all the old atomic models, what is the modern one like?
Well, the modern one is quite fascinating. Let's take a look at it. Before I start, I'll tell you about Heisenberg's uncertainty principle. Imagine that you are blindfolded and you threw a ball at a moving chair. What will happen?
The chair will move away from its original position and the ball will bounce back.
Right. Now, imagine that the ball was a photon, and that the chair was an electron. In order to observe behaviors of an electron, we must observe it with photons. But the problem is, you won't know where the electron was or how fast it was moving before you observed it. Just like the ball in the chair, you might know where the ball is now, but you don't know where it was. So in reality, we cannot exactly determine where an electron can be found, but we can calculate the probability of where an electron is in a particular area, known as an orbital. There are 3 quantum numbers used to describe the state of an electron. The principal number tells us which shell the electron is in. The azimuthal number describes how fast the electron is orbiting, and the magnetic number tells us how the electron is oriented in space. No two electrons can have the same states. That means there cannot be 2 electrons in an orbital shell. If it happens, the 2 electrons must be spinning in opposite directions. That's the basic idea of the modern atomic model.
And that's why our substance within the orbitals, because all the electrons can fit into one shell.
Exactly.
I learned so much today. I need to go home and process all this information.